which would go higher? A ball thrown up from the top of a building 34.3 meters tall at a rate of 9.8 meters per second, or a ball thrown from the ground in an upward direction of 19.6 meters per second. So which goes higher? I don't know. It says graph the path of both balls and then figure it out. So let's graph each of them. So let's do height 1. Let's call it height 1, h of t. We'll just call it h1. So that's thrown from 34.3 at 9.8 up. So it's in meters, so negative 1/2 times 9.8 t squared plus my initial velocity. Just want to make sure I get it right. 9.8 t plus 34.3. My second equation would be negative 1/2 9.8 t squared plus its initial velocity, which was 19.6 t, plus from the ground, so 0 is the height. And I want to know which goes higher, which means I want to know which vertex has a greater y value. Because if I can figure that out, then that's the higher place. So so this will be purple, and this will be green. So let's do green first. The vertex, so h1 is equal to negative 4.9 t squared plus 9.8 t plus 34.3. Now we need to complete the square to find the vertex. So I'm going to subtract 34.3 from both sides. h1 minus 34.3 equals negative 4.9 t squared plus 9.8 t. Divide everything by negative 4.9. And I get h1 minus 34.3 over negative 4.9 equal to t squared minus 2t. Now I'm ready for my completing the square plus blank plus blank. Half of my negative 2 squared is 1. So 1 is the number I put in there. Completing the square, this is t minus 1 times t minus 1, t minus 1 quantity squared. Now I'll subtract 1 from both sides, so I get h1 minus 34.3 all over negative 4.9. Multiply both sides by negative 4.9, so h1 minus 34.3 is equal to negative 4.9 times this quantity squared plus 4.9. So now I add 34.3 to complete my solution, and I get minus 4.9 t minus 1 quantity squared plus 38.2. So the vertex here, after 1 second, it gets to 38.2. If we want to graph that, well, let's find the second one first before we get too crazy, because we want to know what our graph needs to look like. So let me erase that one, completing the square piece. And I'll do h2 over here in blue. So h2 is equal to negative 4.9 t squared plus 19.6 t. Now fortunately to solve this one, to get this one into vertex form, let's see. I still need to complete the square. But I don't have any c value to deal with, so I'm going to divide both sides by negative 4.9. t squared minus 4t. So to complete the square, I take my b value, cut it in half, square it, which means I need to add 4 to both sides. So I will do that. So now I have t minus 2 quantity squared, so it's going to take 2 seconds for it to get to wherever it needs to go. And I'm going to subtract 4 from both sides just to save myself a step. And now h2, multiplying both sides by 4.9, negative 4.9 t minus 2 squared plus 4 times 4.9, 19.6. So after 2 seconds, this gets to 19.6. So when I'm throwing it from the ground, gravity holds it down. It only gets to 19.6 feet, which isn't even as high as the initial building. So not even close, but let's graph them both. So I need to get 38.2 on this graph. So I'm gonna treat each jump as 5, 5, 10, 15, 20, 30, 40. Okay, so 38.2 after 1 second is here. After throwing it off a building, 34 meters tall. So it starts from there, then goes to here. So that's 1. And then the other starts from the ground and gets up to 19.6 after 2 seconds. It has a symmetric point. I know it's going to fall to the ground symmetrically, so I know it's going to hit the ground after 4 seconds. So those are the two paths. How much higher would one ball go than the other? Well, one went up to 38.2 and the other went up to 19.6, so I'll subtract the 2. To get 18.6 meters higher. So more specifically, the first ball will go 18.6 meters higher than the second ball. They're thrown at the same time. Which one hits the ground first? Well, my picture could be really bad here. So let's find out when they each hit the ground. I already know when the second one hits the ground. It's at 4. When does the first one hit the ground? So when h1 is 0, what is t? Let's find out. So subtract 38.2 from both sides. And then divide both sides by negative 4.9. 7.8. 7.796. Try to round as little as possible. T plus 1 squared. Sorry, t minus 1 squared. So then I take the square root of that, and I get 2.792 equals t minus 1. Add 1 to both sides. Of course, that's plus and minus. So then I get 1 plus and minus 2.792, which I know the positive is the only one that makes sense, so 3.792 seconds. So it seems like it does in fact hit the ground a little bit sooner. One hits it after 4 seconds, the other hits it after 3.792 seconds. So H1 is the answer for that. But just by a little bit, a little more than 0.2 seconds. So that's that.